here. I'm now asking you about limits as x approaches infinity. This is different than what you've done, but you actually know exactly how to do this. If we're talking about going out towards infinity, either positive or negative on your graph, I'm talking about the horizontal asymptote. Do you guys remember with rational functions how to find the horizontal asymptote? Top heavy, bottom heavy, equal, that sort of stuff, okay? So see if you can evaluate. Top heavy is slant, yep. So I'll give you a few minutes here, guys. Yeah, it's 2x squared minus 7 over x squared plus 1. Yeah, the 2 got kind of lost in the line there.
Is number 1 2? It's 2, right? That's I think you're talking about horizontal squared. So you can find 2 divided by 1. The first one is horizontal. Wait, but bottom heavy, what is it? It's using 5 and coefficient. I remember it.
Good, you know stuff. That's exciting.
That's what I have in horizontal. Oh, yeah, they are. You're right. You're right. You got it. Equals to you're right. Oh, yeah. So,
yeah. Yeah. Divide the top by the bottom. No, like long division. Divide the whole thing.
So we have to do one.
Yep.
So I'm just confused with this. You know, 3 times 6 is 3x, right? Multiply by each other and subtract what they add, right? So we're going to get 5x. How many times 4 goes into this?
No, how many times does x squared go into that, which doesn't work?
So just 3x?
Yeah. Because we don't care about the remainder.
No, it's just the only thing about here. Thank you.
Yeah.
Well, just leave one.
Yeah. Number 3. Yeah.
What do we do?
We are learning about finding the slope of a tangent line. Basically, the limit definition of a derivative.
Whoa.
That's not hard.
It's not hard. It's like algebraic heavy. You know, like lots of simplifying algebraic.
So it's bottom heavy right down horizontal
That's the remainder, right?
I looked it up. I gave you a good few names.
Wait, how do you make sure you're able to do synthetic division?
Yeah.
It's going to be linear, so you can't divide by x squared.
I got one. No, like I wrote then 0 and 3.
It feels like the middle of the year. It's almost May. A week from Sunday is May.
That's crazy.
Right?
It feels like only
Will actually feel like
I have no idea.
Okay.
I got 2.
How we doing, guys? You've got to think about the last one a little differently. That's doesn't follow your normal rational function rules, okay? Think about what that graph looks like. We've actually graphed it before, so.
Oh, it's so long.
Kind of.
The last one. Yeah. Hey, is that someone that's like someone that's like this? So, okay. I just had the plug-in for it.
That's okay.
Yeah.
It matters whether you're going to positive infinity or negative infinity.
You know what? All I see is
All right, guys, let's go through them. See where you are. Okay, so number one, this is just a rational function, and if I'm talking about the limit as x approaches infinity, I want to know where the horizontal asymptote is. So guys, is number one top heavy, bottom heavy, or equal? Okay, so what does that mean we do? So where is the horizontal asymptote? 2, right? It's here. You don't have to sketch anything else. You know that the graph is somewhere up here. It doesn't even matter what happens in the middle. You know the end of that graph, whether it's above or below the asymptote, is going to follow the horizontal asymptote. That's the whole point of it, is to tell you what the end of your graph is doing. So the answer to this first one is 2. Okay. Second one there, limit as x approaches infinity. Another rational function. Is that top heavy, bottom heavy, or equal? So what's the answer? 0. Okay. All right, number 3. Rational function again. This one's top heavy, right? That means you have a slant asymptote. So let's think about how we find the slant asymptote. What do I do? Yeah, if synthetic works, go for it. Because I'm dividing by x squared, I need to use long division. So you could certainly put your placeholder in, like it's good to be in the habit of that. But because both of these skipped a term, it wouldn't really matter. And I'll go ahead and do it this way. So I know I need a 3x. It's going to give me 3x cubed plus 0x squared minus 12x. Subtract all of that. We get 5x plus 1. What is that 5x plus 1? Okay, do we care about the remainder? Okay, so your horizontal, or I'm sorry, your slant asymptote is the line y equals 3x. Okay, so you know that's doing that, right? So as x approaches infinity on your graph, and again, it doesn't matter if your graph is in this part or if it's in this part over here, it's going to follow this asymptote. So as you go really far to the right, where does that go? Infinity. This is one where it's okay to just have infinity as an answer. I'm asking you about x approaching infinity, so it's okay to just tell me infinity. 3x is not the limit. 3x is the asymptote, and then you have to figure out, based on that asymptote, what is the limit. So you were almost there. Does it make sense to you how I'm getting the infinity out of that? Okay. If I had asked you as x approaches negative infinity on this one, what would you tell me? Yeah, because if you go left, the graph is actually going to go down. Okay. All right, number 4, this is not just a regular rational function. We've graphed this before. This is the one where you've got this piece going here, and this piece going here. If you plug in 1, 2, 3, you get +1 as your output. If you plug in -1, -2, -3, you get -1 as your output. And you cannot plug in 0. So as x approaches -infinity, where's your graph going? -1, yeah. Okay? Questions? So quick little, not lesson on infinite limits, but kind of knew most of the pieces already. You just hadn't seen it in limit notation. Okay, any other questions before we jump into your notes? All right. Go ahead and get out paper today, guys. You are doing your own handwritten notes today.
I'm just gonna take that as a compliment.
All right, guys. 10.3, we are starting with slope of a tangent line, which is really your limit definition of a derivative. Okay. A couple terms I want to make sure we're okay with before we get started. First one is secant line. Not secant like that, like geometry secant. What was a secant line? Does anybody remember?
Like a chord.
Like a chord, okay? How many times does a chord intersect a circle?
Twice.
Yeah, so a secant line is a line that touches a curve at 2 points. So we'll draw a little picture here. Love the graph. So guys, that is a secant line because it touches this other curve in 2 points. So the other term we want to define is tangent line. Anybody remember what a tangent line is? You just,
Oh, it's the one that touches one point.
yeah, just in 1 point. So a line that touches the curve at 1 point. So I'll draw a tangent line here. It intersects your curve at exactly 1 point.
Is there a reason they should the same name just like a trig function?
No, I wish they didn't because it's your brain's like, wait, I'm thinking about tangent as sine over cosine, and then that's not at all what we're doing. So no, it's just inconvenient. All right, so now we know what secant and tangent lines are. I'm going to draw another picture for you here. So kind of a parabola shape, doesn't really matter. I've got point P. And then over here I've got point Q. And point P I'm going to label as x, comma, f of x. And then let's draw in, I'm drawing in a little bright triangle here, kind of connecting P and Q. I'm going to call that horizontal distance there between P and Q, I'm going to call that H. We're not going to call the Y part anything, it doesn't matter. So if P was x, f of x, what do you think Q is going to be labeled?
Y.
Yes, x plus h. Do you see it? That's how far over we've gone. And so then instead of f of x, what is it going to be? There you go. Because you've traveled over that horizontal distance of h, so we're just adding that to our x value. Okay, if I connect P and Q, what kind of line is that? A secant line, right? It intersects the curve in 2 points. Okay. We are going to find the slope of the secant line. It's really loud. Okay, so let's think just basic slope of a line. How do you find slope of a line? What is it?
X2 minus X1, or the other way around. Y2 minus Y over X2 minus X1.
Exactly, yeah. So difference in your y's over a difference in your x's. Rise over run, change in y over change of x, lots of ways you can say it. So I want to find the slope between P and Q. So my slope would equal, I'm going to say Q's the second point there, so f of x plus h, that's the y part, minus f of x over, yeah, because it's going to be x plus h minus x. So if you simplify that, it is f of x plus h minus f of x all over h. Stop there so I can make sure everybody's caught up with me. Does that part make sense so far? Okay, so if I want to find a tangent line here, let's say, I want a tangent line just at P. How do I find the slope of the tangent line. Let's think about this for a minute. Okay, with the secant line, it was easy because we actually had 2 points and you could just use the slope formula, right? Okay, what you're visualizing that is happening now is that Q is getting closer and closer and closer to P, okay? Don't draw this part. Let me get rid of my blue line here. So let's say Q had moved to here. And again, don't draw this. All right. That's getting closer to a tangent line at P, right? And then what if Q moved even closer? What if Q was here? You guys see how that's approaching this tangent line? So what is happening to H as I keep moving Q closer and closer? Getting smaller. What is it getting close to? 0. Okay. So to find the slope of the tangent line, you're doing the same thing that we did for the secant line. We're doing this f of x plus h minus f of x all over h, but we're doing the limit of this as h approaches 0. Because we need that h to get as close to 0 as possible, and then we actually have the slope of the tangent line. I'll let you jot it down and then we'll talk more. This is a very important thing to write down here, okay? We're going to write that a lot today. So with the tangent line, you're technically still using P and Q, all right? But you're trying to get them as close together as you possibly can, because you still need your 2 points to find the slope of the line. But you want them almost a distance of 0 away from each other. Does that make sense? Okay. So a derivative it's the limit used to define the slope of a tangent line. So that limit statement we wrote up above, that is the limit definition of a derivative. Now we're going to learn lots of ways to find derivatives. You're going to learn shortcuts, power rule, product rule, quotient rule, implicit, all these different ways. But it all starts with the limit definition of the derivative. It takes longer to do it this way than the shortcuts, for sure. But sometimes you'll get a question where you can't do it with the shortcut. You have to understand the limit definition. So we're going to practice some of those today. And just notation-wise, symbols that mean derivative, that's called f prime of x. That stands for a derivative. Sometimes you'll see dy dx, which is dy over dx. You might also see y prime. There are lots of different ways to write derivatives, and they mean different things. These are the most common ones that you'll see in here. All right, so let's try one. All right, so number one here, find the slope of the tangent line to f of x equals 3 minus 2x minus 2x squared where x equals 1. Anytime you see the words find the slope of the tangent line, that means find the derivative. Okay, so we're going to find the derivative. And right now, the only way you know how to find the derivative is with the limit definition. Okay, so I'm going to write that limit formula again. Limit as h approaches 0 of f of x plus h minus f of x all over h. That's what we have to solve. So there's a couple of ways you can go about this. You can go through the whole problem leaving the x in there and then substituting the 1 in at the end. Or you can substitute the 1 in right from the start and then evaluate the limit from there. I think that's a little easier just because you eliminate a variable, and so it's simpler to work with. So that's how we're going to do it. So our first step, limit as h approaches 0, and yes, you have to write that limit statement every time until you've evaluated it. So we're going to find f of 1 plus h minus f of 1 all over h. Okay, you can do the work in the limit, but then you have to keep writing limit, limit, limit over and over. So I would go off to the side here and figure out, well, what is f of 1 plus h? Like, what does that actually mean? Okay. What am I asking you for when I say f of 1 plus h? Yeah, so I've got this f of x equation. Instead of x in the equation, I need to plug in a 1 plus h. So I'm going to have 3 minus 2 times 1 plus h minus 2 times 1 plus h squared. So we can keep distributing, simplifying all that stuff. So this is 3. It would be minus 2 minus 2h, and then minus 2 times, well, what is 1 plus h squared? H squared plus what? 2h. Okay. Plus 1. Okay. So simplify a little, distribute the negative 2. So you've got negative 2h squared minus 4h minus 2. When we finally simplify all of that, what do we get? Negative 2h squared minus 6h minus 1. Okay. I'm going to go over here, limit as h approaches 0, and I'm going to write all of that. That's what f of 1 plus h is. So negative 2h squared minus 6h minus 1 minus, what else do I need to find? F of 1. So again, go off to the side, find f of 1. This one's a little easier. 3 minus 2 times 1 minus 2 times 1 squared. What do we get for f of 1? So we have minus negative 1. Yeah. And then all over h. Let me stop there for a minute, make sure you guys are caught up. Yeah. For today, yes. So once you learn the shortcuts, like finding the derivative is easier, but there will still be problems where I say, do this with the limit definition, and you have to do those this way.
It's just mostly old, right?
It is so much algebra. The actual, like, the limit part is just the formula, like you know how to evaluate that. It's so much algebra with the simplifying and plugging it in. That's what it is. So, yeah.
Will there ever be like a problem that, like, assuming your teacher doesn't say use this way, like the limit definition, that you have to do this for?
There could be one where, like the way it's written, like that it doesn't actually have numbers, like that I'm asking you to evaluate certain things that like find the slope at x equals a or something weird like that where you wouldn't be able to do it, but most of the time, no. Okay, a little more simplifying here, guys. We're almost there with this. Limit as h approaches 0. So are you okay? Well, what's left in the numerator, guys? Negative 2h squared minus 6h, right? Does everybody see that? Could I factor that? What do you think I want to take out of it based on what's in my denominator? Yeah, I don't really care that I can take a 2 out. That's fine. I really want to take the h out, okay? So I'm going to write h and then minus 2h minus 6 all over h. Are you guys okay with me jumping to that step? If we see that the 1's canceled and then I just factored it. Okay, what happens? H is canceled. And then what am I doing? Like what am I trying to find? The limit. Can I evaluate the limit now? Yeah, this is what we're doing in 10.2, where you get those things to cancel out so that then you can just plug in the value. So I'm plugging in 0 for h. So what do I get as my limit? Perfect.
So like, going back to like the visual example, when exactly would h equal 0? Like,
So let's say you've got this graph. I don't know, it's an upside down parabola. Something's going on, right? So if I want to find, like, here's x equals 1. I want to find that slope, right? I can't find that with just one point on my curve. So what I am essentially doing is going, okay, I now have 2 points really, really close together, and I'm going to find the slope of that. You want those 2 points to be so close together that the distance between them is 0. That's the h approaches 0, is like those points are just right on top of each other. Does that help a little?
oh yeah.
Okay. And so guys, what this is telling you is if you graphed our curve, which was some sort of upside down parabola, the tangent line at x equals 1 has a slope of -6. Okay, that's what that -6 is. It feels like you just get a random number at the end, but that's what it's telling you. It's the slope of that tangent line at that specific x value. Okay? Are we okay? They're tedious. They're not really hard. They're just tedious. Okay?
Pretty much you're just putting 2 points infinitely close together and then finding the line that they make.
Mm-hmm. Yep. All right, I'm going to switch slides. Let's try again. Okay, so let's do it again. We're just going to do lots of evaluating these limits, lots of algebra today. All right, find the slope of the tangent line to f of x equals 1 over x minus 1 at x equals 2. Do you guys want to try one, or you want me to walk you through another one? Try it? Okay. Remember, you are doing this. Yep.
So if we can't just have like a lift, we can't just stop right in there.
Nope. You have to have it in every step, or you'll get eaten alive in calculus. Because once it's gone, that means you've evaluated the limit. And so if you haven't done that yet, it doesn't make sense what you're doing. It's just a lot of algebraic simplifying, like.
It's the warm on the next. We added it.
Oh, yeah, that makes a lot of sense.
That will be easy.
We're overcomplicating it.
You should get just a number answer at the end. Once you're there, check in with someone around you. It's okay if you're getting lost in the middle. I'll walk through it too. Got to find some common denominators at one point.
No. That's
Oh. What did you say next to them?
you're asking me that's
Oh.
So a lot of things do cross out. So when these H's cross out, which they do. Otherwise, yeah, that's fine. All right. Oh, yeah. They're tedious. I know. Yeah. Okay, good. See some people still writing, so we'll wait another minute here, guys, and then we'll see what you get. Some of you are still writing. Some of you look like that problem sucked all the life out of you. I don't know. He's still alive. I don't know if Neil's still alive. Might not be. Okay, guys, what did you get? Number did you get at the end? No one wants to say what they got. It's really close. -1. And Neil's alive again. That's good. Okay, let me walk you through it. So again, off to the side here, do my work, f of 2 plus h. So that'd be 1 over 2 plus h minus 1. Are we okay with that as 1 over 1 plus h? Okay, we'll plug that guy in. Oops. All right, and then f of 2. Everybody okay with that's just a 1? Okay. And then all over h. So guys, you need a common denominator here. I will have 1, and then be careful here, you're distributing the negative, so 1 minus 1 minus h over 1 plus h. And then guys, it's divided by h. Are you okay with me calling that times 1 over h? Are we okay with that? Do we get that divided by h is the same as times 1 over h, right? Divided by 2 is the same as multiplying by 1/2. Okay. Because what happens with that 1 minus 1 in the numerator? They die, they cancel out. Yeah, those are gone. And then what happens with the h's? They cancel. What do you need to be careful of there, though?
Negative.
Yeah, keep that negative. So that's really -1 over 1 plus h. Let me rewrite it just because that got a little messy. So you have -1 over 1 plus h. So when you plug 0 in, what do you get? -1. Yeah, Milan. You cannot do that. Think if I have like 3 over 3 plus 2, you can't say that that's 1/2. Okay. Yeah, if you can't do that, you just somehow got lucky with your mistakes working out. Yeah, you maybe broke some algebraic rules in there. And these are ones where I look at your work, guys, because you're gonna, a lot of these, once you learn the shortcuts, like you can just look at the original problem and go, oh yeah, that should have been -1. So I'm not just gonna look at your answer. You should definitely check that way, but I'm gonna check your work if I ask you to use the limit definition. I will teach them to you, not on Friday, because that's a religious observance day, so Tuesday of next week, you will get the shortcuts.
Is there any reason why we would use this way?
Yes, because you have to understand this way for calculus. Like, you will definitely get AP Calc questions that say, using the limit definition, and you have to understand what that is. Where there won't be numbers, there'll be only variables, and you can't simplify it with the shortcuts. Okay? So, yes, it's not often that you have to use it, but you have to know it. All right, let's try another one. Yeah. Sure. Okay, so are you okay here with the common denominator? So that numerator would become 1 minus 1 minus h. That's what's happening here. It got scribbly. 1 minus 1 minus h. Over the 1 plus h, common denominator. Then divided by h is the same as times 1 over h. Are you okay there? Okay. 1 minus 1 is 0, so that's gone. The h is canceled. But it was negative h, so that's why the negative is still in the numerator. Then from here, you're just plugging 0 into h. That helps? Okay. It got a little messy at the end there. Can you wait a second here before we do another one? Let me rewrite this step. Okay, that's what this becomes. Will become okay. So 1 minus 1 is gone. So you have negative h over 1 plus h. And then divided by h is the same. Okay? So it's negative 1. Yeah. Okay, let's try again. All right, number 3, part A. Oh. Find the derivative. Well, you don't know. Maybe there's a part C. Okay, f of x is equal to the square root of x. That's it. I will start you off on this one. If I'm asking you for the derivative, that means find the slope of the tangent line. Now, this problem, I didn't tell you at which specific x value I wanted you to find the slope. So you're just going to find the general rule for the slope of the tangent line. And that is finding the derivative with that limit definition. So you're going to start limit as h approaches 0. And I know we've written this a million times today, but I'm writing it again. I want it stuck in your brain. F of x plus h minus f of x all over h. Okay, what is f of x plus h? We don't really have to do work off to the side on this one. What do you say? Yeah, square root of x plus h. Minus, what's f of x? Okay. All over h. All right. We're trying to evaluate this limit. We can't just plug 0 in for h because we get 0 in the denominator. When you had square roots in your problem and you were evaluating limits in 10.2, what did you do to fix that problem? Conjugate. What is the conjugate going to be this time? Square root of x. But yes, yeah, you had the right. So square root of x plus h plus square root of x. Okay, should I multiply out everything? No, just the numerator, right? What do I get when I multiply that out? Okay, x plus h minus x, so yes, just h, right? Okay, so all of that turns into h over h times the square root of x plus h plus the square root of x. What happens? H is cancel. What's left in the numerator? 1. What do we do now? Plug in 0. What do I get? Two root x. Are you missing anything? Yeah, 1 over 2 root x. And you can leave it like that. You do not have to rationalize. So that is the derivative. If you wanted to write it, you'd say f prime of x is equal to 1 over 2 root x. Pause there a second.
Oh,
Perfect.
so there are no shortcuts if it's just variables.
So, like, after the next lesson, you'll be like, oh, yeah, that's 1/2 x to the negative 1/2, which means 1 over 2 square root of x. Like, I can just look at the blue part and tell you the answer at the end once you know the shortcuts. There are certain problems that you have to do with the limit definition. Today you have to do it because I'm telling you have to do it. Eventually I'll be like, no, do the shortcut. But there are certain problems that you can only do with the limit definition. But it's not like general derivatives. It's like weird things going on in the problem. Okay.
So on the first and second step, we got like x plus h, how do we just get square root of h plus x?
So since f of x is root x, if I'm replacing the x with x plus h, like that's all it is. Oh, that's a plus now. You're substituting again. Okay. All right. That was 3a. No, it's not bad. So part B, you are now going to find the slope at the following 2 points, 1, 1, and 4, 2. These are not hard, okay?
Just plug in x values for x.
Yes, you just plug in the x values. That's all I'm asking you to do. You already have this right here, means slope, okay? Slope of the tangent line. Now I'm just telling you at a specific point. We don't really care about the y value of this point. We care about the x value where this is happening. And so you just plug in that into your derivative. So I'm going to say f prime of 1 over 2 times root 1. So you've got this general rule for the slope that you can use at any point along the curve. My original graph of f of x equals square root of x. If I went to an x value of 1, the slope of that tangent line is 1/2. Okay? Then, next point, here I care about the 4. So if I go to an x value of 4, the slope of the tangent line is what? 1/4. Okay? Perfect.
So what we were doing in the first part is just finding the formula for the tangent line of that function.
Mm-hmm. Yep. Because the slope, like, think about your graph here. It is square root of x, something like that, right? Do you see how every tangent line I draw, like, that's going to have a different slope than that?
Yeah.
So the slope changes as you go along the curve, but it's always going to follow that formula. Just the x value changing changes what the slope is. Okay? Other questions on that? Okay. Let's see. All right, let's do number 4. Find an equation for the tangent line. Sorry guys, I can't read my own notes. To y equals x squared at the point 1, 1. Okay, guys, if we're writing an equation of a line, what do we need? We need slope. So we got to find slope. Y-intercept, or what's it like? Yes, we know this form, y equals mx plus b. What's another form we know? Point form? Point slope form? Yeah, what is that? Yeah, it's y minus y1 equals m times x minus x1. Okay? So if you have a point and a slope, any point, it doesn't have to be your y-intercept, you can write the equation of a line. So I know I already have a point given to me, right? I've got this guy. And what do I know about finding slope of a tangent line? It's everything we've been doing today, okay? So yeah, you're going to find the derivative of y equals x squared. So you're going to do the limit as h approaches 0. And I know we have a y instead of an f of x, but it's the same idea here, okay? So you're going to have f of x plus h minus f of x all over h. Now you've got two choices here. You could go all the way through with the x still being in there, or what could I plug in right away? 1. That's what I'm going to do. So I'm going to change my little x's to 1s. Okay, what is f of 1 plus h? I bet you can do it in your head. What is it? Yes, h squared plus 2h plus 1 minus, what's f of 1? Okay. Take out an h. It's 2. Okay. So. So we have our slope of 2, and we have our point of 1, 1. All you do is plug it in. You don't have to like solve for y or do anything extra. You can always leave it in point slope form. So you're going to write y minus 1 equals 2 times x minus 1. And that is your answer.
How many more examples do you have?
1. And then I have not an example, just how a function might not be differentiable.
We have to find the equation for a line if we aren't given points on the line.
I'll give you at least the x value if I'm asking you to find the equation of the line. Because usually if I'm asking you to find the equation for the tangent line, it's at a specific point. But I might only say like when x equals 3. Well, could you find the y value if you know the x value? Yeah, you just plug it into the original equation. Okay? Yeah. From the 1 plus h to the h squared. So we know, I know it was written as y, but that's f of x is equal to x squared, right? So if I'm doing f of 1 plus h, that's that quantity squared. So you might have written it as 1 plus 2h plus h squared. Do you see it? Okay, same thing. I don't care which order you put it in. Because it's just squaring that quantity, like 1 plus h times 1 plus h. Yeah? Yeah. Okay. Are you guys good? Yeah. Okay. I just want to make sure. I don't want to move on if you're like, no, I don't know what you're talking about yet. Oh, yeah. That one I was like, you can do it in your head. You know it if it's right. Sorry, guys. I just don't want to switch till we're good. All right, you guys are gonna try this one. I think I'm on 5. All right, find the equation of the line tangent to f of x equals 3 over x at the point 3, 1. Okay, you guys try this one. You've got your point, you need your slope.
What would you start making this with a vector? Or just
Nope, I would just do the tangent, like the limit part. Yep. The secant one is really just there to help you understand the idea that what we're doing is taking those 2 points, moving them as close together as we possibly can. No. So what you're doing, so this is f of x. F of x plus h would be 3 over x plus h. And then this would be minus 3 over x. Yeah, so that 8. And then you'll need a common denominator. A little bit of fraction work in this one, guys. Common denominators. Yeah. Yes.
Oh, yeah. It is like the
Is that this? Yes, that's the same.
Yeah.
Oh, yeah. Or plug in for after that.
Yes, and you can stop here if you want to. You like that better? Okay. The only thing I would say is if you go to that and you look at the state going to that.
Oh, yeah.
I know. So just
What do you
like,
want, what do you want from home?
All right. I read that. It's hard. So for yeah, of course.
just a while ago.
Pretty quick. You know me back.
Oh, she did. Yay.
Yes, and she said that the student she was trying to pair me up with already got it too. So it's like, okay, all right, and
Well, at least you have closure on that and you weren't
Yeah.
just wondering.
just like leaving me hanging.
Yes.
She told me.
That's good. That's
Yeah.
good. Well, the kids missing.
I just wanted to let you know, just in case, to leave you hanging.
Oh, yes, I appreciate
Yeah,
that.
I completely forgot about this. Like, you're not.
Good. I do that all the time. It's like, or you remember it, but not a convenient time
Yeah.
at all.
And then you just like, it just
yeah.
disappears from your brain. You're like, I thought about it.
Yep, exactly.
Done. Not really.
Made room for something else in your brain. Yeah. How we doing, guys? We getting an equation of sorts? We think we got an equation? I see some people still working away. Let's wait a minute.
Plug in. Alright, after that.
To make an equation.
What is 3 over x? Alright, 3 over x. Yeah.
It's just asking for an equation.
Sure.
Okay, select.
Yeah.
It's problem 2 right now.
Now, what is that?
So I need to
Yes.
Tired, Matthew.
A little bit. So the h no, the x minus yeah. Yeah. Real which is what is 3
Guys, I'm going to write the answer up here. Don't look until you're ready.
This sounds really good.
Why is that x minus
3. I don't know. Because I'm tired. Still on the 1-1 from the last problem. So check when you're ready. I'll walk you through it, guys.
What
That's like I don't know what happened. Especially last year we did these last years. I never did anything. Like he voted for them and like literally I don't know who anyone was.
Yeah, if you can't read your own handwriting in these, it gets real tough. Neil, in your perfect handwriting. Pretty perfect. All right, guys, how many of you got it? Okay, that's pretty good. Pretty good. All right, let me walk you through it. So limit as h approaches 0. So f of x plus h, that would be 3 over x plus h. Minus f of x, that'd be minus 3 over x. All over h. Are we okay with that initial setup? First step happens there. Okay, your common denominator that you need here. It's x plus h times x, like you actually need both of those things. So this one, you're taking numerator and denominator times x. X plus h over here, okay? So this becomes 3x. And then it'd be minus 3x minus 3h. Careful with your negative there.
Why didn't you just plug in x?
Oh, the 3, I forgot. So I'll do it this way and then plug in the 3 at the end. You can do it either way. You'll see why maybe you like doing it the other way better. Do you guys see how the h's are going to cancel? Okay. So I can plug in the 0. And I know the x value is 3. There's your slope. And then that leads you to your answer. See, if you forget to plug the x in right away, plug it in at the end. It still works. Okay. But it'll work in either part. You'd still have to find a common denominator if you plug the 3 in early. All right, let's stop there for a second. Questions? Any part of that you need me to walk you through? Yeah, I didn't plug it until the end. Why are there so many x's? That's why. It's really not harder. It's just.
It looks harder.
It looks harder?
Yeah.
Okay. Well, but you'd have to distribute a 3 to a 3 and an h instead of an x and an h. Right? It'd be 3 and oh, because it would cancel out on the one. Okay. Fair. Fair. Yeah, I agree.
How do you know?
Are we okay? Yeah. Do you want me to do it with the 3 in instead of the x? Okay. Do it again. So f of x plus h, or f of 3 plus h. That f of 3 would be 1. Are you okay there? So your common denominator now, you just need the 3 plus h.
It's just option 22.
I don't know.
I think option 22 is an outstanding decision.
Are you okay with that, Greg? So 3 minus 3, those are gone. We've got negative h over 3 plus h, and then I'm going to say times 1 over h. They cancel, plug your 0 in, you still get negative 1 there. Okay? Yeah, no problem. All right, we doing okay with it, guys? It's detailed. You got to pay a lot of attention to your signs. It's not hard, but it's, you know, algebra work. Okay, one more thing. All right, 3 common ways. Ugh, can't write. For a function to fail to be differentiable at a point. If we're saying fails to be differentiable, that means you can't take the derivative. Okay, that's what differentiable is talking about. First is the graph has a sharp point, or sometimes it's called a cusp. So graphically, this point right here, where it comes up and then it's a sharp point changing directions, that is not differentiable at that point. It's differentiable in all these other places along the graph, but not at that specific point. Okay, so let's draw the tangent line there. Okay, there it is. Or is that the tangent line? Or is that the tangent line? Or you could draw an infinite number of tangent lines. So how do we know which one it is? We don't. Okay, second way that it might fail to be differentiable is the graph is discontinuous. So let's think if I had a graph. How do you draw the tangent line where that jump is? Like where would you put it?
You don't.
You don't. This is why that's not differentiable, okay? It makes sense. You cannot find the derivative there. All right, and then the third one, the graph has a vertical tangent line. So what that would look like on a graph, maybe like y equals cubed root of x. Right at that inflection point in the middle, you actually have a vertical tangent line. What's the slope of a vertical line? Undefined. So if the derivative is the slope of the tangent line, that's weird, and it's undefined, you can't do that, okay? So that's the third common way. Yeah.
So it feels like y equals x.
Okay.
It's a straight line.
Okay. So that's one. You're absolutely right. It's a straight line. So the tangent line follows that line, and what would the slope of it be no matter where you were on the line?
Negative.
What's the slope of that line? What's the slope of the line y equals x?
Okay.
Just 1. The derivative of y equals x is 1.
But then wouldn't it intersect at like,
It like just follows it.
but like
I know, it's weird, but
crossing over it, like it's touching there more than you want to.
that's how it works. All right, guys, you made it through Probably the most tedious notes of the unit, okay? So, there is 10-3 homework available, and guys, I'm gonna change the due date. Friday is a religious observance day, so it's just gonna be a work day for you. So I'm gonna make the homework due Friday night, like after, so you have class if you need to work on it. And I'll make the second attempt.
Like, you can start worksheet in class or no, just nothing for this work. Okay. Well, that's
If you have stuff for other classes, that's fine. Okay.